Hi, so this is going to be laboratory one for me, and this is what I'm choosing to do, the chemistry of hand sanitizer and soap. This is from the American Association of Chemistry Teachers, and when I found this specifically underneath organic chemistry for their classroom resources. They have a lot of really neat resources. This was the one that was free, so I'm thinking about getting a subscription to this, paying for that, or having the school pay for that. So, anyways, this is what we're doing today. We are looking at this lab focuses specifically on molecules and bonding and intermolecular forces, polarity, and molecule structure. So, specifically, we'll be focusing on hand sanitizer and soap. Hand sanitizer does contain alcohol in it, it's primarily alcohol. And if we recall back to what we learned about alcohols, they have the functional group, the hydroxyl group, which helps relate to its polarity. Now, this is interesting for us because we are in the middle of a global pandemic and we have learned quite a bit about the structure of viruses in the past year. We've learned a lot about sanitation practices, and I think overall we've gotten a little bit better with that. So, what we need to do is we are going to focus on first what is the structure of a virus just in general. You've learned this in your biology class perhaps, but we're just going to go over a brief crash course on this. So if we're looking at a virus here, viruses can have their genetic material on the inside, and that can either be DNA or RNA, but that's not relevant for us at the moment. So these viruses are going to be encapsulated with something called a capsid. So that's a protein coat surrounding it. And then you can have some viruses that also have a envelope around this as well. And this can be from the host cell that it infects. It can take those membranes, that cell membrane from that host cell, and it can use that to encase it into its own membrane for the virus. And then also on this membrane, you can have scattered throughout these proteins here. So all of those spikes that you see on the COVID-19 virus, those are going to be those protein spikes that we see there. So all of these are organic structures. These are going to be very common structures found in living organisms. Okay, so going back, so we have the basic structure of these organisms. And then also, I would show this video. I'll include this in a typed up report here, but I would show this video, soap versus hand sanitizer. It goes into a lot of the good chemistry behind it. So I would show this as well beforehand. We'll focus on it later, but right now we're going to focus on performing the lab here. Okay, let me pull that up. Okay, so for this lab, we will need 2 small paper plates, which I have these little trays here. We're going to use with what we got. Tap water, I'm using distilled water since I'm performing this at my desk so I can have a camera here. So we're using a bottle of distilled water. We need black pepper, so I have some black pepper for us to use. We have 1 drop of liquid soap, so this is a soap I am using. And also we are using hand sanitizer, and this is a hand sanitizer I bought in the beginning of the pandemic, and we can see 62% alcohol, and it does smell like alcohol like a lot of the off brands that we have. Okay, so we need to make sure we are keeping things safe. So anytime you perform a lab, even if we're just using household chemicals, but to have good practice, we need to have our hair tied back, long pants, closed-toed shoes, and of course our safety goggles and aprons. So that is what we are going to be using. So I'm putting mine on to get this started. Okay, so those are the safety features. So we're going to go through the procedure here. All right, so it says step 1, add tap water to 2 empty paper plates. So I'm going to go ahead, I'm going to unscrew this bottle because I think that would be A little bit easier than trying to squeeze it in there and making a bigger mess. Okay. Some cords in the way. All right, I don't think the amount necessarily matters here. I'll try and make it a little bit more even. I think my desk is crooked. It's good to know. It's a new classroom for me, so I'm getting used to it. Okay, next it says, sprinkle black pepper flakes onto the water surface. So these black pepper flakes are going to represent our virus here. I can't get this open. There we go. Okay, so this will represent our virus. We have our nonpolar fats and proteins that will surround our virus coating, as I described earlier. So remember, these viruses are not going to be soluble in water, so that will be represented by these pepper flakes. So I'm just going to dump those in. Okay. Hopefully I don't sneeze. Oh, I got a lot in that one. Okay. That looks pretty good. All right. I also forgot to mention I'm going to use, it's not written in the lab directions, but I think this will be easier. We do toothpick with this, but we'll see. Actually, I'm not going to use a toothpick. I think this will be easier if I just drop it in. Okay, so we're going to use a drop of soap into the first plate. So we'll make this plate, this first plate, the soap plate. And before I do that, I need to make sure I'm going to be describing my observations in the data table listed. So this is the, I'll show this. This is going to be the data table. So I need to observe as I'm doing the lab, the soap versus the hand sanitizer being added. Okay. The lab says use the likes dissolve likes principles whenever we are describing this procedure. So we're going to use soap in the first tray, hand sanitizer in the second tray here. Okay, so time for my soap. I'm just going to put in a drop here. Let's see what happens. Okay. I think I put too much in. There's a bunch stuck on the bottom. Okay. There we go. I put a drop in, put a few drops in. And I'm going to do hand sanitizer next. Okay, it's a little bit different of a reaction, but it still helps disperse. I don't know if you can more or not. Okay, so I think I put in too much pepper, but because this is all stuff that sunk to the bottom, and a lot of that sunk to the bottom too. But looking at these two plates here, the one with the soap dispersed it the most in this case. But if we look at the hand sanitizer, it did disperse the pepper here. And if we look at this from a perspective of, what is surrounding the virus, is it just going to be, it's going to have the membrane around it, it's going to have just the protein coat, the capsid. So the shape of the capsid itself can actually affect which is more effective, soap or water. But if you look, they do both have some effect here. And the video that the students would watch over, let me pull it up again, this video, which is better, soap or hand sanitizer, it does describe towards the end of the video how hand sanitizer is better in for some viruses in some cases. Okay, so this is the lab. So for cleanup, what I would tell students to do, they would just dump this down the sink. which would normally not be a big deal because it would be right next to the lab stations. Obviously, I don't have one next to my desk, so I'll probably have to carry mine over. But they would just take this to the sink. Probably would have them throw this away. These trays, I wouldn't necessarily have them keep them unless I was running low on supplies. Then I would just have them do a rinse. We didn't really use anything glassware related where I'd have to rinse them out with tap and distilled water, so I don't think that would be an issue here. So after I would have students clean it up, I would have them answer the analysis questions that were provided in the lab, and I am going to add more questions for that so it relates a little bit more to alcohols and functional groups, since that is where I'm going to be including this lab into the lecture and also the course that I'm creating for this organic chemistry unit. So that is it for this lab, and thanks for watching.